Past and present Northwest College science professors John Enger, Dave Barkin, Bruce Watney, and Alan Childs held their final science circus on April 12, 2008.
We want to thank you for coming to our science circus. We like to do this. I'd like to introduce to you who we are. There is Constable Childs. Boom Boom Barkin. Wizard Watney. I'm Egghead Inger. We hope you have a good time watching us tonight. We hope that things work. We enjoy doing this type of thing, even when they don't work.
I just have a couple of quick questions. How many of the adults in the audience have seen this when they were children? How many of you have seen it more than once? Okay, well, welcome back. And those of you that haven't seen it yet, I hope you have a lot of fun tonight because, as Egghead said, we really enjoy doing this. So, with that, I will turn the stage over to Wizard Watney.
One of the things that is in our surroundings that we just take for granted is the air. Now, most people, when you ask them about air, they think about oxygen and things to breathe. But there's another aspect of air, and that's one that we want to hopefully demonstrate for you this evening. Here I have a 55-gallon drum that is just sitting here looking very innocent. And I hope I can put the cap on. I know it's not supposed to be. The wizard alarmed me. We have some hot plates under there. And I look back here, it wasn't plugged in. I said, Wizard, how is this going to work? He said, I just unplugged it. I really do want them electrified before the water. Okay. Well, he said just leave it here. Leave it there. That's what he said. Okay. Wizard, is that a UPS barrel? It looks like it. Could be. We'll see what it delivers. Don't open it. We got this brain burp that if we lay this in a sack, we won't have to clean up the water. What's the purpose of this? Oh, we want to have a real cool barrel. A barrel of fun, okay? We'll see if we can give you a little bit of, let's see, what do they call that at the very beginning of a film that shows you what's going on? Trailer. Okay. Here we go. You have to watch because this happens fast. Ready? Another country heard from. Let's try that one more time. Interesting way to crush a can. So we have it in the small and we have it in the large. So this will be an ongoing thing. So Mr. Allen. Oh, I ought to explain how it happens, shouldn't I? Forgot about that. Well, what happens is around us, there's some air pressure. At sea level, you have 14.7 pounds per square inch on every surface, okay, including these things. And there's about, maybe probably 300 square inches on this thing. And so I put some water in here, boil the water, fills the thing with steam, water vapor. When it does, it pushes the air out. And so there isn't any air in there. All there is water vapor in there. And then when I flipped it over and stuck it in the cold water, what happened is it sealed the top. So air can't get in. But all of a sudden now, the water that was water vapor now becomes liquid water, and it occupies much less volume. And so the air pressure on the inside is very low, but the air pressure on the outside is still high. And so it crushes it. So pop cans are really easy, no problem, even though there's probably 600 pounds of force on this thing. No wonder it crushed. So how many tons of force are there on that thing? Many. Many tons. And so as time goes on, I don't know if you can see it or not, but it's starting to kind of scrunch in because the air pressure on the outside is pushing it in.
I brought my magic bottle tonight. It forecasts the future. And could you look in there and tell me, is it going to get up to 70 degrees tomorrow? No? Not sure? How about you? You going to get straight A's this semester? How about you? What do you say? Oh, I forgot to put the magic solution in there. No wonder they can't tell what's going on.
Maybe we should have named you Egghead, huh?
Maybe, but night is young. Time will tell.
Is that really good stuff?
Yeah. This is even better.
And it tells you anything you want to know?
Well, we'll kind of see what
You ask them?
what happens here. Okay, we got to start mixing it here. I don't know, how about you? Can you see anything going on in there? Is it going to hit 70 degrees tomorrow?
I hope so.
You hope so. You going to get straight A's this semester?
Yeah.
No doubt. I don't know, that's looking pretty black in there. I better shake a little harder then, right? Oh, I don't... You seeing something I'm not? Uh-oh, uh-oh, uh-oh. Something has happened here. Would you look into my bottle and tell me who's the most important person in your future? Who? Who do you see? Me. Oh, okay. Do you have an antique silver mirror with real silver on it? Well, they didn't shake it like this, but they used the same chemical reaction to make it.
Is that silver?
That's silver.
Oh! Oh!
Jolene, are you afraid of electricity? Come here. Yeah, come here. Come on. Come on.
Paybacks, Mr. Birkin, paybacks.
This is payback for reminding me.
I was pretty sure of that.
The reason we don't use children as volunteers on this one is because it's dangerous.
Bye.
Come here, come here.
It usually doesn't work anyhow.
Well, first of all, this is called a Tesla coil. Tesla was a very famous scientist. And just to give you some idea, ouch, how hot this might get.
Got some water? There you go.
Okay, so are you ready?
Is that electric?
Yes, it is.
Oh,
Okay, now, there's a couple of things we got to worry about. I'll do it first. But all I want you to do is when I hand this over to you, this is awful dirty, we should have cleaned it up. I want you to grab the other end when I tell you. Just make sure you don't touch the metal. Because I've heard you scream before.
Brilliant, brilliant. Illuminating. Aha. Doctor. What's your name? Sarah. Where do you go to school, Sarah? Parkside, what grade? Is your teacher here? Okay, good.
Is your mother here? Is your mother here?
Uh-oh. That might not be so good. We're going to try to make Sarah disappear. And Sarah, don't worry, we're going to try real hard to make you come back again. Here's my box. And as you can see, it's just a black box. No tricks inside. And Sarah, I just want you to get in the box. Comfortable? Take your last look. Okay, Sarah's in that black box there. And she doesn't know what's going on out here. She doesn't know what this is, for example.
It's fake.
You okay, Sarah? Is everything going okay, Sarah? Woo! Suppose we lost you already? We got some little stickers. Boom, boom, give me a hand here, or our constable's over there. That's all right.
That's not a sticker.
We're going to stick some of these through Sarah. Uh-oh. Sarah, you got a problem? Sarah, are you still there?
Nope.
I'm going to peek and see if she's still there. Okay. I didn't see her. Okay, let's get this story back. Let's get these little ones in here now. We just won't worry about Sarah. One,
I had something there.
two, three, five, hey, are you counting?
1, 2, 3, 4, 5, 6. I got 7.
Oh, I guess that's enough. She should be a pincushion by now. Let's take a look. You ready, Mom?
She's gone. She's gone. Where did she go? She's gone.
these little things. Skewers.
Whoa!
Uh-oh. Uh-oh. You got anything like this? Uh-oh. We better get these out. That one was all full of blood. Just a few more. Did you hear us, Sarah?
Oh, she's back.
Should we let her mother see her if she's there?
Maybe she wants to come up and look first.
Well, let's just see if Sarah's there. Tell us what you did. Come here and tell us what you did. Because it's an empty box. Where were you? Show us what you did when you got in there.
It's an army of.
Just get in there and show us what you did. Yeah. Now just go ahead with the doors open. What did you do when you first got in there? Can you remember? And the sword, of course, went down in the front of the gap, so you couldn't see the edge of the mirrors. And all the little stickers either went along the front, the back, or at an angle. And then those in front of the mirrors you saw an image of, so you thought there were twice as many, hopefully. If you didn't see it, there it is again. And the mirrors just allow you to see a nice view of the side of the box. And Sarah, of course, is in there behind the mirrors, just wondering what in the world we're going to do to her next. Thank you, Sarah. Well, eggs are interesting things. They're good for breakfast. You can have them poached or scrambled or hard-boiled. And sometimes you hard-boil an egg and you stick it back in the refrigerator because you didn't get it eaten. And you know, when they're hard-boiled, they look like just the rest of the eggs. And the question is, how do you tell them apart? Well, there's a little physics that you can use. Here's an egg. Okay. Here's another egg. Why is that? Well, because this one's hard-boiled, and it acts like a solid. And so when you spin it, you keep spinning. Okay? This other one is like a liquid. And so you can spin the outer portion, but the inner portion doesn't spin. So it stays there. Now remember that, because Constable Childs is going to show you something along that same line down the line a little bit. Now, another thing that you can do with an egg, hard-boiled egg, is to see if you can put it in a flask. Yeah, well, let's try that. What's happening to our egg?
Going down.
Yeah, it's going down. Why is it going down? It's sucking it in, yeah. Not quite, but almost. Now let's see you get it out. Yeah! How do you get it out? Well, you could try squeezing.
No, that won't work.
That won't work. You're right, that won't work. Well, how about if we use an air dryer?
Oh, yeah.
Now the reason that works is for the same reason that the pop cans crush, and the same reason that the barrel over here is looking kind of peaked. Because when you cool air, it contracts. Its volume gets less, or its pressure gets less. Well, the volume can't get less because it's the size of the flask, but the pressure can. And when the pressure on the inside gets less, the pressure on the outside pushes the egg down. Okay, so you flip it over, and then what happens is the egg is a cork. And so now you heat the air up. The air inside tries to expand. It can't. The pressure increases greater than the outside pressure, and so it pushes the egg out. So now you know how to deal with eggs. What you got there, Constable?
Well, you know, we're kind of close to halfway through the show, so we have to have a commercial. We have to advertise our sponsor here tonight. So I'm going to just tell the folks the initials of our sponsor and see if they can figure out who our sponsor is.
N is W. Northwest College.
So who's our sponsor? All right. I think the paper's name, color's name is Galaxy Gold. And it is, the color in there is acid-base sensitive, so I used a little ammonia here. You could probably smell that right there in the front row. And turns Galaxy Gold red. Our sponsor thanks you.
What's that?
Jolene, are you afraid of heights? No, just kidding. There goes my discount at the bookstore. Let's see, I need a nice, very athletic kind of guy. Is there any Northrops in the audience? Is he athletic? Or did you leave those two boys home?
No, I don't leave anyone home anymore.
Have you done this before? Good. Are you afraid of heights? Are you fast?
Kinda.
Kind of? Okay, I'd like you to climb up to the third step. Okay, now I know that's kind of high and you're not supposed to, don't stand on this one because it says do not stand, don't even sit on that one, okay? Too bad I didn't see that when I was painting yesterday. Okay, I have this little thing here that fits in this copper tube.
Okay.
Now, what I want you to do, I'll give it to you in a second. Now hang on there, I don't want you to fall down. Okay, I'd hang on to this. I'm not so sure how good. I'd hang on to the ladder. Thank you. What I'd like you to do is drop this in the top, and as quickly and safely as we can. I wish we had some bungee cords to the ceiling, but we don't. Try to catch it before it comes out the bottom. But the rule is you have to touch these two steps. You can't just jump off.
Okay.
All right? And there's one other thing you have to be careful of. You can't put your hand on the floor.
Okay.
If you put your hand on the floor, it's going to hurt.
Okay.
I've done that. Okay, it hit, when this comes down, it comes down pretty fast. It's going to hurt you. So I want you to be careful coming down, and then you can get yourself ready. You can kind of get ready. As long as you have one foot on that third step, and you're ready to go. Oh, no.
Very good, Ben.
Go ahead. Now, you got to let go before this foot moves.
Okay.
That was close. Good try.
That was a pretty good try. I don't know if I should let him try it again. This can't be touching that step yet. You got to. Okay, you can be. Yeah, there you go. Okay, well, that was a really good try. You could go sit down. I really appreciate it. I know that I'm really old and I don't get around like I used to, and somebody even mentioned about how I used to wear a different pair of coveralls years ago. And so what I'm going to do is I'm going to show you how this is done. Now, Ben, I'm not near as young as you are, neither am I near as fast as you are, but I'm going to give it a real shot, okay? Boy, that's a long way down. Anybody have any idea what I did? Pink. Yeah.
Did you switch it in your pocket?
Switch what? No, this is the same pipe that was here before.
Same ladder.
It's the same ladder.
Same pin?
I did. I switched it, Ben. I cheated. I have two that look alike. Did anybody see me change them? You didn't, did you? Okay, I've been doing this a long time. I know how to talk and move my hands so you don't pay attention. That's what magicians do. And I switched them. One is a magnet and one is not a magnet. But why does the magnet come down slow? Because this is not magnetic. Neither one of these stick to that or to the aluminum ladder. Okay, the pink shirt.
Because on the inside is a metal tube that sticks to that.
No, it would stick to that. What's inside is another piece of copper. What I did was I have two pieces of copper pipe, so I have more copper. So there is metal, but the metal is copper. And copper is not magnetic. Okay, what happens is, have you ever looked in the engine of your car and you have an alternator in there and it's got wires wrapped all around it, copper wires, and there's a magnet that spins? Well, what happens is when the magnet's moving, it causes electrons in the copper to spin, which creates a magnetic field which opposes the magnet as it goes down. I think this is the one that's not a magnet. So you can see quite a difference. Now, if you, somewhere I have a very strong magnet, if I can get them off.
Uh-oh.
This one will take a while. Still moving, I can hear it. There it is.
Let's see, we were looking around for a little guy here, about like you over there with your hand up. You'll come out there, mother? Yeah, right here. Great shirt. Yeah. You don't believe it? Now I can't get out. We would like to have you be a person who tests a bridge for us, an engineer if you like. And this is going to prevent any problem, like we hope. And this is going to be the abutments of the bridge. What's your name?
Matthew.
Matthew? Where are you from? Which school?
I'm on homeschool.
Matthew, what's your last name, Matthew?
Wait.
This is Matthew Wade. He's homeschooled. What grade? Third grade. Are you brave? That's good. Have a seat right there. And where's our tape measure here? And move your support over the edge. Move your table as far as you can. Still need to be farther. That's longer than the tape measure. Plan ahead. Well, hold it there. Hold it there again. What was half of it? What was the whole thing? I'll tell you what happened. 132. Okay. That'll do it right there. Okay. Whoop. Right in the center here. These are our bridge building components. Sit down and face the audience and try to smile. And this is your stack. Is that correct? No, it isn't, is it?
I don't know. You stack them.
You stack that side. Okay, here we go. 1.
1.
2, you think we'll ever get to you? 3. 4. 3. One of us can't count. 4. 5.
5.
6. Well, we've got a long ways to go. 7.
6. 7.
8. Boy, it looks like we're very short.
8.
It's going to fall.
Let's start sticking them out farther.
Okay. 9.
It doesn't fit. Hey! Did we use any nails?
No.
Screws? Glue? What holds it there? Just its weight, gravity. The center of mass of this whole pile is right back here at the edge. As it balances, just barely. And here's something that you can take to your dad over there, and just give it to him like this, and have him grab a hold of this end, and he'll tell you something about center of mass. Let go of it. Why do you want to turn it around, Neil?
Because it has a funny center of mass. The center of mass is down the middle.
Okay, the center mass of that one is very close to his hand. Had he not turned it around, he'd have a hard time holding it because the mass would be way out there. Well, the center of mass of this pile is right at the edge of the support. Make sense? Thank you. Now everybody knows about stoplights, right? Yeah. Well, what color is this one? Yeah. That's a good question. But you know, you really wouldn't make a very good stoplight if it just stayed green all the time. It's fine for you if you're going through. But how about for the other guys?
Stop.
Yeah, they'll have to stop. Well, it stays green for a while. Watch it. And eventually you'll see it turn back to orange and then turn back to yellow. See, it's fading already. There we go.
I can see it go to yellow.
What color is it now?
Red.
Wow.
Yellow.
So you're telling me if I shake it up again, it's going to change color again, huh?
It's like your swimming pool got deflated.
Yeah, your bed of nails. Took out what the top. Before I do this, back in 1990, I put my daughter Devin, who was at the time 7 years old, in a soap bubble, and one of the pictures that you saw was her in the soap bubble. Devin, stand up. She's not 7 years old anymore. I won't tell you how old she is, but you could figure it out. 7 in 1990. Anyway, my granddaughter Megan is here, so in a minute, Megan, I'm going to have you come down. I'm going to try to put her in a soap bubble. But before I do that, I'm going to try to make some soap bubbles. Yeah. This gets a little messy. You've been wondering probably why we have this humidifier down here making us all hot and muggy. I don't know about you, but I'm sweating.
Yeah.
And the reason we have it down here is because we're going to try anything to make a soap bubble. So I'm going to set this fan up here, and I'll see if I can make a soap bubble. Hard to do this in.
See if you can get the end of your tie in there.
I'm trying. Okay, well, we'll give up on that for a minute. Try to pour this in here. There's my, I didn't mean to put it in this one. Okay, Megan, come on down. Why I don't wear ties in the lab. How old are you, Megan?
9.
So you're a little older than your aunt was when she was in the soap bubble. So if you would climb up there and stand on that block. Okay, and keep your hands to your side, and I'm going to try to lift this up over you. Oh yeah, turn the fan off. Do another one. That one actually was great.
I agree.
You interested in having a rest on a bed of nails?
Didn't you used to do this all the time?
Yeah, but I got punctured, I guess. I thought you were going to do this for me.
Yeah, all right.
Did you bring an apple along?
Yeah, I did. What did I do with it? It's around here somewhere.
Try it out. See if those nails are sharp. Now, Boom Boom thinks he can lay on that bed of nails, and he's probably right. Go ahead, lay down there.
But that's cute.
Watch your butt. Now, Boom Boom is a chemist, and I'm a physicist, and so we thought we'd use this book just for good luck. It's a little outdated, but we're kind of outdated too.
Speak for yourself.
Now, the rest of the story that Boom Boom isn't quite so certain about is here's another one, just like that.
Oh, man.
A little bit smaller.
Now he's a
I
Santa.
told you, that's a slope.
And we'll give you some protection, Boom Boom. Old welder's helmet. And just for the rest of you. Now you're wondering, why isn't he punctured and all that? Well, he's laying on probably 1,000 nails. And he may put 100 pounds on there. That's a tenth of a pound per nail, which isn't a whole lot. You can probably feel it, and you're not going to see him wiggling around very much. But we'll just help him out here. Can you breathe?
Barely. Oh. Get off, John.
I know that stack was never that crooked for me.
Oh no!
What do you think will happen if I take this after Boom Boom here? Are you ready, Boom Boom?
Yeah.
Get your arms tucked in.
Yeah.
Are you ready? How long can you stay there?
Not long.
Are you there?
Yeah.
He's okay.
One of you. I don't know if you heard it, but one of his admirers said, "He's okay." Let me just have you think for a moment what we did there. That hammer seemed to be a cruel addition to everything else. You can see how he could handle the weight, though it was somewhat hard to breathe, because they had so many nails and the weight per nail was relatively minimal. But with the hammer, would you have allowed me to take that hammer and just hit the board?
Yeah, if it was on the floor and I wasn't underneath it.
Yeah, because if I just hit the board, the total force of that hammer would have to be dissipated directly on him. What I tried to do was to accelerate 3 concrete blocks with that hammer. You try accelerating 3 concrete blocks. It doesn't work. So as a result, did you feel much when I hit the block?
No. I did not.
You were already out cold?
I was having a hard time breathing. All those years I made you wait, you finally got to make me wait, Jeff.
Let's have a hand for Boom Boom. Well, some chemical reactions are very fast. And near the end of the program, Boom Boom is going to show you an extremely fast chemical reaction. Some reactions are slow. Okay, they are kind of like rusting. You can sit there and watch it for a long time, and you never really see it happen. You go away a while and come back, and you can see it happen. Well, some reactions are kind of in between. So, let's see what happens in this one.
I can't see it.
Can't see anything? I don't either, but keep watching. Yeah, about time. So, let's see what else we can do here.
Got a beaker filled with some water. I've got a little boat in it. And this is your little hint. I give the beaker the table to spin. If the boat stays in the middle, it doesn't move till it comes to the edge. Now I'm going to replace that with something else.
Uh-oh.
Now it has to do with fire. Give that a little spin. Not very exciting.
Now?
So maybe we ought to have a bigger flame.
Yeah. Egghead, you can come in here.
Looks like it's under control.
I guess so. I guess you didn't need me after
I
all.
didn't need you after all there.
What was the function of the screen?
Why did the screen turn that flame into a tornado?
It's going off by itself.
Going off by itself?
Yeah.
What's that mean?
It's getting smaller and smaller and smaller.
How come Boom Boom couldn't put his fire out with a piece of paper?
I have no clue. Why did the boat not turn in the middle of my beaker until it hit the edge? What was the function of that screen?
I don't know.
Don't know.
Because the stadium went back and the water was spinning.
And the water was spinning. The water took a while to spin. And once it did, then the boat turned. Same thing with the air. The function of the screen was to spin the air so that the air was going in a
Circle.
tornado type fashion, a circle, and eventually a flame tornado appeared. Where'd Egghead go?
Outside.
Outside. That flame really made it hot in here. I was wondering if he was going to get me a glass of water or even better, a root beer.
Oh, yeah, I forgot.
You got root beer?
Here it is.
You sure that's root beer?
Yeah,
I have a sip.
yeah. How's it taste?
Like root beer.
Oh, that's wonderful. Thanks. I'd like to be able to do that in your house over your mom's table. This is called a Greek waiter's tray. It's got a hinge up here so that no matter what I do, it just follows where this follows. And since this is almost at the center of gravity, remember, of this system,
It just stays there stationary. It's not attached. And it is just real root beer. There's no trick to it except the center of mass. And I don't want to hit anything.
As soon as I bring the bubbles up, I'll tell you to cover your ears. Notice I'm wearing ear protection, so hang on here a second. Okay, cover your ears. Okay, cover your ears.
I have a really strange solution. I don't know how well you're going to be able to see this, but can you see this? The color on this thing? Yeah, it's purple. But there's something strange about it. No. Okay, let's see. How about turning off the lights there? Can you see that half of that is colored and half of it isn't? And this side is pretty much colorless. This side is pretty purple. And now I'm going to switch it. As you watch, the side that was dark is becoming lighter, and the side that was light is becoming darker. You see? Okay, that's one to look at. And one more here. Right. Thank you all. You've been a wonderful audience. We've had a lot of fun. We hope you did too. Thank you.
From Powell, Wyoming, this is NWC TV.